In this lesson, we'll look at different forms of linear equations in two variables. The most familiar form is slope-intercept form, y equals mx plus b. This is the most useful form for graphing or writing equations of a line when given slope and y-intercept. Remember, m stands for slope and b stands for y-intercept. Let's see how easy it is to write equation of a line given the slope and y-intercept, and then we'll recall how to graph such equation. So, since we have the slope, we have our m. Okay, we can start writing our equation. M is negative 2/3 x, and we also have y-intercept, which is 4, so our b is 4. And we have our equation. Now, graphing is really easy because we don't need to calculate anything. We start with y-intercept, plot the y-intercept on the y-axis, that's our 4, meaning that this point belongs to the future line. And then we go by the slope. Slope, as we remember, it's rise over run. So to obtain the next point, we're running 3 steps forward, and we're falling 2, falling because it's negative 2. So running 3 up to here and falling 2. That's our next point. Okay, so the line will have to pass through these 2 points. We're ready to graph. So let's take a ruler and graph this line. Let's see the next form of linear equation. That's a slope point form. If we know one point that belongs to the line with coordinates x1, y1, and we know the slope of this line, this is the easiest form to write equation of a line. We use the slope m here. X and y are the variables, however x1 and y1 are the coordinates of the given point. So we just plug in our information to the formula and we have equation of a line. The only thing that we should do after that is to open the bracket and clean up everything and maybe rewrite in a slope-intercept form, leaving y on one side and everything else on the other side. Why do we like to use this form instead of slope-intercept form? Well, because this is easier to write equation if we have given slope and some point, not y-intercept but some other point. Or if we have given 2 points on the line. Knowing the 2 points, we can easily calculate slope, and again, using slope point form, that seems to be the easiest way of obtaining equation of such a line. Notice that this slope point formula of a line comes directly from the definition of a line. Let's recall that a line is a set of points with a property that any pair of chosen points from the line will have the same slope. So if we choose the first point to be the given point and the second point to be arbitrary moving point along the line with the variable coordinates x, y, they are changing. No matter where the x and y is, the slope between these 2 points is always the same. So if we calculate slope, we do difference in y coordinates, y minus y1, this part, over difference in x coordinates, x minus x1, so that part. So you see, if we start with this general definition of a line and we multiply the whole equation by x minus x1, then we end up exactly with the slope point form of a line. It will be m times the bracket x minus x1 on the other side. Let's see example how to use the slope point equation of a line to write equation of a line with slope -1/2 that will pass through the point -4, 3. And then we'll graph it. Okay, let's recall how our slope point formula works. Y minus the y coordinate of the given point, which is 3. This is our y1, so minus 3. And then this is equal to slope. We are lucky we have given slope, so -1/2, times x minus the x coordinate of the given point, marked by x1, and our x1 value is -4. So watch this part, we have double negative. First negative from the formula, x minus x1, that's our x1, and second minus because the value of x1 is negative. Okay, since we already have written our formula for equation of a line, what's left to do is to simplify it. So let's multiply through the bracket. We'll get negative 1/2 times x, and these two negatives makes it positive, times negative, it's altogether negative. 1/2 times 4 gives us 2. In the meantime, we can move the tray to the other side, so it becomes positive 3 on this side instead of on the left. And the left side is just simple y. Okay, finally, y would be equal to negative 1/2 x. 3 minus 2 is plus 1. So we change our slope point form into slope-intercept form, which is the easiest to graph. So how do we graph it again? We start with y-intercept, we mark it on the y-axis, that's 1, and then we go by the slope. Running 2, run is the bottom number, so we run 2, and falling 1, fall 1, so that's the next point at 2. Okay, again, take a ruler and graph the line. Notice that just for graphing this line, we didn't have to have equation of it. It was enough to have the information that the line passes through the point negative 4 3, so we could mark negative 4 3 over there, and then go by the slope negative 1/2, meaning 2 steps across and 1 down to get the next point, and the following point, and the following point, and the following point. So we can develop quite a few points to be more exact. Okay, so we have the equation and we have its graph. Let's see another application how to use slope point form of a line. This time we need to write equation of a line that passes through two given points, and those points may have some fractional coordinates. Okay, let's recall one more time our slope point formula of a line. Y minus y coordinate of a given point equals slope times x minus x coordinate of the given point. So what we need is slope. We did have slope given in a previous example. Now we don't have slope, however we can calculate this. So on the side let's find out what's our slope. Difference in y coordinates. So we can go 1/3, starting with this point, minus negative 1/2, over, if I start with this point, into denominator I have to start with the same point. So 5/6 minus 5. And then we need to simplify this complex fraction. So let's multiply the top and the bottom by common denominator, which in this case is 6. That gives us 6 times 1/3 is 2. 6 divided by 3 is 2. And then it's plus 6 times 1/2, that's 3, over. When we multiply 6 times 5, 6, the 6 will disappear, will be cancelled, and we get 5. Minus 5 times 6 is 30. So overall we have 5 over negative 25, which can be reduced to negative 1/5. Okay, so we have our slope. Let's use it. Y minus, and now we need to pick which point we are going to take. Well, let's take the point that has less fractions, so I would take the first one. The y coordinate of this point is negative 1/2. Again, watch double negative here. Equals, take the slope, which is negative 1/5, and in a bracket x minus the x coordinate of our point, 5. It doesn't matter which point you choose. You can choose this one or you can choose that one. When you simplify this equation, the result will be exactly the same. You may want to check it on your own for the second point. Okay, let's simplify this. Y plus 1/2 equals, multiply through the bracket, negative 1/5 x, and two negatives makes it positive. 5 divided by 5 is just 1. In the last step we need to bring the 1/2 to the other side, so we subtract 1/2. Y would be negative 1/5 x. 1 minus 1/2 is 1/2. So that's our linear equation. The next form of a linear equation is standard form. This is a form ax plus by equals c, where a, b, and c are relatively prime. That means you can't reduce them anymore. We also like to keep a, b, and c as integers. So if there are any fractions, we can always multiply by the denominator to get rid of those fractions. And finally, we like to keep a positive number. So if by any chance it becomes negative, we can always multiply the whole equation by -1 to start with a positive a. Okay, let's make a record of this. We like to have a, b, and c integers. That's our double-braced z. We like to keep a positive, and we want greatest common factor of a, b, and c to be 1. That means if we can reduce them, we do that. Okay, when do we use this form? Well, this is the most useful for graphing if x and y intercepts can be found quickly. What does it mean, found quickly? Basically, if c is easily divisible by a and c is easily divisible by b, then it's worth to think about x and y intercepts. Why? Because if we want to calculate x-intercept, then we replace y by 0, so this part disappears, and x is c over a. So if c over a can be easily calculated and plotted, then it's worth to go for this method. Also, y-intercept is when x is 0, so this part disappears and the y can be calculated as c over b. Again, if this fraction is nice, then it's worth to think about taking y-intercept and plot it. The third indicator, slope, we figured this out in one of the previous videos. It's -a over b. So we divide the coefficients a and b and we change the sign. Okay, let's see how this method can be used when graphing equation of a line given in a standard form. We calculate x-intercept. So x-intercept is c over a, 12 over 3 is 4. And y-intercept. Y-intercept is c over b. So 12 over -4 is -3. So that's how easy we can get x and y-intercept. And we can plot it. So x-intercept is here, 4. Y-intercept is -3 over there. And now it's enough to connect those 2 points by a line. Let's do that. Here's our line. And 2 more special forms of linear equations. Horizontal line can be stated as y equals a constant, because y can be constantly at the same level and x can move. So x is everything, y is at the same level, we end up with horizontal line. This can be seen in a slope-intercept form as 0x plus b. So we can see easily that the slope is 0 and the y-intercept is b. And the second type of special line is a vertical line. This particular line has equation x equals a constant. So this time we keep x at the same level and y can oscillate. Y can be anything, so that gives us a vertical line. Since we don't have y here, we are unable to express this particular equation in a slope-intercept form. However, knowing that it's a vertical line, the slope is undefined and the x-intercept is obviously a. Okay, let's practice. How do we write equation of a line that has undefined slope and passes through the point 2, 3? Remember, undefined slope describes a vertical line. So our equation must be of the form x equals to a constant. Okay, we can write x equals, but what could be this constant? Well, since our line passes through the point 2, 3, the x must be 2. So our equation is x equals to 2. Let's graph it. X equals 2 is here, and then y can be anything, so the line looks like that. And as you see, the point 2, 3 is indeed on our line. That's our point 2, 3. And second case, write the equation of a horizontal line that passes through this point, and then graph it. Horizontal line has equation y equals to a constant, and our constant y must be 5 because the line passes through this point. So y equals 5. Okay, let's graph it. Y equals 5 is here, therefore the horizontal line that passes through the 5 goes like this. Obviously the point -2, 5 is on our line. Now another example asks us to write the equation of a line parallel to the given line that passes through the point -2, 3. Since our future line must be parallel to this one, the slope of this line and the desired line must be the same, because parallel lines have the same slope. So let's calculate slope from the given line. To do that, we can either solve for y and find out the coefficient by the x, or we can use the formula a over b and change the sign. So -1 over 2, but we have to switch the sign. Okay, so that's really 1/2. One way, or if you don't remember this way, you can always solve for y. For example, 2y equals x plus 7. Therefore, y by itself is 1/2 x plus 7/2. So indeed, our slope is 1/2. Okay, but all these calculations were done for this line. And from having this line, we're taking only one information, 1/2. The rest should be forgotten. Just 1/2 is of our interest, just the slope. So, to write equation of our future line that passes through this point and it's parallel to the given one, we use the slope 1/2 and we use the given point -2, 3. Now, using slope point formula of a line, let's write our equation. Y minus y coordinate of the given point equals the slope x minus x coordinate of the given point. Now, to simplify this, we multiply through 1/2. So it's 1/2 x plus 2 times 1/2 is 1, so plus 1. And to get the final answer, we just bring the 3 over to the right. So our final equation in slope-intercept form is 1/2 x plus 1 and plus 3 is plus 4. Okay, so that's our answer in slope-intercept form. If someone wished to have this answer in standard form, what we need to do is multiply everything by 2 in order to get rid of this fractional coefficient. So it will be 2y equals x plus 8. And then starting with positive x, so let's keep this on this side. Let's bring the 2y to the right, however 8 to the left. So we end up with 8 equals x minus 2y. Obviously this can be written starting with x, so we can just change the sides. X minus 2y equals 8. That would be the standard form of our line. And that's slope-intercept form. And one more type of questions that you may get, write the equation of a line that is perpendicular to the given line and passes through the same point. So maybe let's picture out the situation. What did we have in example A? We had this purple line given. We took the slope of it and the point that is somewhere on the plane, not necessarily on the line. We wanted to write down the equation of a line that is parallel to the purple one but passes through the given point. Okay, now in this case we have the same line given, the same purple line and the same point. Let's say it was here. But what we need to do is to write equation of a perpendicular line that passes through this point, perpendicular to the purple line but still passing through the same point. The point is not on the purple line, is somewhere in the plane. So what we do here, we are calculating the slope of this given line. As before, this is our 1/2, slope 1/2, and then we are forgetting about this equation. We're not using this anymore. What we do, we change the slope into perpendicular slope. So let's mark slope perpendicular is opposite reciprocal of the given slope. So it's -2. Okay, so our future line will have perpendicular slope, which is equal -2. And now using this slope and this given point, let's do the same as before, use slope point formula of a line to find out the equation of our line. So y minus the y coordinate of the given point equals slope -2, x minus the x coordinate of the given point. Let's simplify this. Y minus 3 equals -2x, plus and minus is minus, 2 times 2 is 4. So when we bring the 3 to the other side, we have y equals negative 2x minus 4 plus 3 is minus 1. That would be our slope-intercept form of a line. If we wish to see it in a standard form, we just bring the negative 2x to the left, so it will be 2x plus y equals negative 1. That will be the standard form. I'm okay if you give just one form as your answer, so slope-intercept form is okay. However, sometimes in textbooks, they could ask you to leave the answer in a standard form of a line. So that's why I show how to change from slope-intercept to the standard form. Again, for parallel line to the given one, we use exactly the same slope. In this case, it was 1/2 here and there. For perpendicular slope, we calculate the slope of the given line, and we need to switch it into perpendicular slope before applying the slope point formula. And finally, an application problem. A rental car costs $50 plus 30 cents per kilometer. Let x represent the number of kilometers driven and y represent the total charge to the renter. Write a linear equation that relates y with x. Okay, y in relation to x. How can we do that? Well, if we have no idea how to do it, let's start with a table of values. So, if x is the input and y is the output, what if x is 0? 0 kilometers driven. How much do we have to pay? Well, we still need to pay $50. What if x is, let's say, 1? If we drive just 1 kilometer, well, they will charge us 30 cents per kilometer, so 30 cents on the top of $50. 50, and instead of adding this 30 cents, let's just observe the pattern, so write down 30 cents times 1, because it was just 1 kilometer. Okay, what if we drive 10 kilometers? Oh, then we pay 10 times 30 cents on the top of $50. So it's 50 plus 30 cents times 10. Okay, generally, if the input is x, then we multiply this 30 cents times the x. So looking at the pattern, our formula should be $50 no matter how far we drive, and then 30 cents times the number of kilometers, so 0.3 times x. To rewrite this in a slope-intercept form, we can say 0.3x plus 50. That will be our formula for the linear relation of y with x. Now find and interpret the y value associated with x equals 5. Okay, if x is 5, that means we replace x by 5, so the associated y will be 0.3 times 5 plus 50. Okay, that becomes 0.3 times 5 is 1.5, plus 50 is 51.5, so $51.50. What is the interpretation in the meaning of the problem? If we drive 5 kilometers, we will be charged $51.50. How many kilometers was the car driven if the renter paid $84.80? Well, this time we know the value, we know the charge, and the charge is y. So let's replace y by 84.80 equals our formula 0.3x plus 50. And we're looking for x to find out how many kilometers was the car driven. Okay, let's subtract 50 from both sides of the equation. So we'll get 3480 equals 0.3x. Then we divide by 0.3 both sides of the equation, so the x would be 34.8 over 0.3. And now we could either use calculator and get the answer, or move the decimal dot one place value here and there and just divide 348 by 3. That should be 116. Okay, what does this mean? This 116 is the number of kilometers driven. So the answer will be the car was driven 116 kilometers.